Hello, geometry students. This is Mr. Allen. Today we're going to look at section 3.3, which is on proving lines are parallel. And I want to make a promise before I start this video that I promise this video will not be as long as the last one. I know the last video was quite long, and I apologize for that. Sometimes it just takes time to get through some of that material. So this one will be shorter. Our objective today is simply to determine whether two lines are parallel. So if I have these two lines here in this picture and they're cut by a transversal, how do I show that they have to be parallel? So there's a couple of key questions here I'd like to start with before we get into the actual lesson. Number one, what is the definition of a converse of a conditional statement? So we talked about this back in chapter 2. We talked about a conditional statement and then what its converse is. So hopefully you remember that a conditional statement might be something like P arrow Q. So what would the converse be? Well, remember the converse, you just take the hypothesis and the conclusion and you change them around. So this is a converse. Now, a more important question to that is a converse of a conditional statement always true? And the answer to that question is no. We saw some examples of that in chapter 2, but we don't always see that that's the case. By the way, if it is true, what do we call it? If it is true, in other words, if a conditional statement's true and its converse are true, what do we call it? I'll give you a hint. It starts with the letter B. So today we're going to look at 4 theorems. These can all be proven. Theorem 3.4, which is the converse corresponding angles theorem, says the following. If two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So this is the converse of the theorem that we had in our last section. Our last section, we would have said something like, if the lines are parallel, then their corresponding angles are congruent. And here we're flipping those around. Here we're saying if the angles, for example, if angle 1 and angle 2 and angle 6 are congruent, then we can conclude the lines are parallel. So we've switched these two around. Okay, so if we went back to section 3.2, we would have switched those around. So let's see an example of applying corresponding converse theorem. It says find the value of y that makes A parallel to B. So line A parallel to B. So the corresponding angles converse says that if the corresponding angles formed are congruent, then the lines are parallel. So in order for the corresponding angles to be congruent, that means they have to have the same measure. In other words, 5y plus 6 has to equal 221, right? Now I've kind of played a little bit of a trick here because technically I'd have to use the fact that these two angles are correct as well, or are congruent as well. So if that angle out there is 121, we know by the vertical angles theorem that angle there is also 121. So now we can go ahead and solve this. We got 5y equals, and then I've got to subtract 6 from that, so that'll be 115. Now I need to divide by 5. So y is going to be equal to 23. So the value of y that will make these lines parallel is when y is 23. Any other value of y, the lines will not be parallel. Theorem 3.5. This is the converse of the alternate interior angles theorem. So again, we're switching the order from last section. So here it says if two lines and a transversal form alternate interior angles that are congruent, then the lines are parallel. So if angle 4 and angle 6 are congruent, then the lines are parallel. Theorem 3.6, this is the same side interior angles, the converse of that. So this one says that if two lines and a transversal form same side interior angles that are supplementary, then the two angles are parallel. In other words, If the measure of angle 3 is, let's say, 100 degrees, and the measure of angle 6 is, let's say, 80 degrees, what's 80 plus 100? Well, that's 180. Then the lines are parallel. And our final theorem for the day is the converse of the alternate exterior angle theorem, which says that if two lines in a transversal form alternate exterior angles that are congruent, then the lines are parallel. So if angles 1 and 7 are congruent, then the lines are parallel. So as you can see, these theorems, this is actually a fairly straightforward section. All we're doing is we're taking the theorems and postulates from the last section, and we're doing the converse of each of those. So in the last section, we would have used the fact that the lines were parallel to show that the angles are congruent. And in this one, we're doing just the converse of that. We know the angles are congruent, for example, and we want to show they're parallel. So here in example 2, I would like to just go through 3 examples. I didn't even type any directions. And my question is are lines A and B parallel? So let's start with this first one here. We'll call this one here we'll call this problem. Let's not call it problem A, because then you might confuse that. We'll call that problem 1, okay? So are lines A and B parallel there? And if they are parallel, how do you know they're parallel? So you might want to pause the video and actually try to do these. So we'll call this one number 1. We'll call this one number 2, even though this is all example 2, and we'll call this one here number 3, okay? So example number 1, I'm going to go ahead and get started. Are lines A and B parallel? I'm going to say yes. A is parallel to B. And now the reason why. Why? Well, let's see here. This angle and this angle. Okay, so there's the transversal. These are on the exterior. They're on opposite sides of the transversal. So I'm going to say by the converse of the alternate exterior angle theorem. Okay, so if we go back, I'm going to go back. It's the very last theorem we looked at, theorem 3.7. The converse of the alternate exterior angle theorem. So that's why these are parallel. So let's look at number 2 here. Those two lines A and B are going to be parallel. And if so, why? This one in a different color. Let's do it in green. Again, I'm going to say yes. A is parallel to B. Why is that the case? Well, in this case, it's by the converse of and what kind of angles do we call those? They're on the same side of the transversal, and then they're on the same relative side of their respective lines. This is what we call corresponding angles theorem. Now, guys, I'm abbreviating here, but converse corresponding angles theorem. So this one's a yes. And so let's go and look at our final example here, example 3. So here it says the measure of angle 1 and angle 2 is equal to 180. So are lines A and B parallel? The answer here is no. They are not parallel. What kind of angles are 1 and 2? Well, angles 1 and angle 2 are what we call alternate interior angles. And if we look back at theorem 3.5, the converse of the alternate interior angle theorem, it says that the alternate interior angles have to be congruent. That is not what we have here. Here, we're told that those two angles are actually supplementary. Supplementary means they add up to 180. So we do not know that these two lines are parallel. In fact, it's most likely the case that they are not parallel. Okay, let's do 2-column proof here. So it says, given that angle 4 and 5 are congruent, prove, which is what we're trying to do in this section, prove that line G is parallel to H. So remember, we're going to do a 2-column proof. I'm going to do this one all the way by hand. So I'm going to make my table here. And on the left side, I'm going to put statements. On the right side, I'm going to put reasons. And let's see if we can figure this out. So I usually like to let my first thing typically is just whatever is given here. So I'm going to just go ahead and start with that. Angle 4 and angle 5 are congruent. That's given. Now I'm going to add a little detail about this. What would you say is true about angles 4 and 5? What kind of angles are those? And I'm not asking like if they're acute or not. When we look at the transversal here, and then these two lines, what kind of angles are those? So in step 2, I'm going to write that angle 4 and angle 5 are alternate interior angles. I hope you would agree with that. They're on different sides of the transversal and they are interior. And since they're alternate interior angles, actually, why are they alternate interior angles? I'm going to put definition of alternate interior angles. And again, I'm abbreviating. Okay, so step 1, I got that they're congruent. Step 2, I have concluded that those are alternate interior angles. So then if I go back to theorem 3.5, which is the very last theorem we were talking about, I can see that we've got this theorem here, theorem 3.5, which says the converse of the alternate interior angles theorem, which says if two lines and a transversal form alternate interior angles that are congruent, which is what we just established, then what can we conclude about the two lines? They are parallel. So now we can go ahead and finish our proof. So this is a very easy 3-step proof. So this is just going to be that angle or line G is parallel to the line H. And that's going to be by the converse of the alternate interior angles theorem. That's the proof. Okay, nice 3-step proof. Now, example 4, I'm going to do just a quick example of what is called a paragraph proof. So I'm not actually going to do a different proof. I'm actually going to just redo this proof here, but I'm going to do it in a paragraph form. I haven't talked about that before, so I'm going to do that now. So the difference between what we saw on that last slide, which was what we call this is called a 2-column proof, because you got 2 columns. Paragraph proof is just what it sounds like it is. It's when you actually just write out the proof. So here I'm just going to write sentences. I'm going to say angle 4 is congruent to angle 5 because it's given. Or you can say it's given that angle 4 is congruent to angle 5. And then I'm going to say we can see that angle 4 and angle 5 are alternate interior angles, comma, by definition. Now I'm going to jump to my conclusion. Since alternate interior, I'm going to kind of go over here a little bit further, angles are congruent, lines G and H are parallel, comma, by theorem 3. I think that was 3.5. I better double check that. Yeah, theorem 3.5. Okay, and then typically when we write a paragraph proof at the end, we put a little box there, but you can put a little square. So that's an example of a paragraph proof. So a paragraph proof is just when you write sentences out instead of doing 2 columns. I personally prefer 2-column proofs, but I wanted to show you a paragraph proof. All right, last example. Says, what is the value of x for which a is parallel to b? So I would encourage you to pause this video and work this one out. I'm going to go ahead and do it now. So this is similar to the very first problem we have. So the first thing I would note is that these two angles are what we call same side interior angles. They're same side interior. So now I'm going to look back, trying to prove that these are parallel. And I'm looking at theorem 3.6, which says that if the same side interior angles are supplementary. Okay, so that means I need 2x plus 9 plus 111 to equal 180. So this is what I need to do to guarantee, and by the way, I'm using the converse of the same side interior angles there. So let's go ahead and work this out. Now I'm doing some algebra, so I'm going to combine these two like terms here, which I think gives us 120. Now I've got a simple two-step equation. So now I'm going to minus 120 on both sides. And that gives me 2x equals 60. Now I need to divide by 2. And that gives me that x is equal to 30. And that's my answer. So when x is 30, these two lines will be parallel, lines A and B. And that's going to end our presentation today.